introduction so that Doug has all the time he needs for the presentation. This session is Advanced Technologies Maximizing Data. In departments of transportation across the country, data analysis is being used to prioritize projects, identify safety issues, inventory assets, monitor construction projects, and target maintenance activities. State DOTs are entering a new era of transportation funding at the state and federal level, and it's more important now than ever that available funding is targeted at the critical needs of the state and where it will make the largest impacts. A DOT collects and has access to large amounts of data and wants to analyze and use that data to inform transportation decisions. This presentation will present examples of how state DOTs are using data and data visualization to make better, more informed decisions, and how those same tools can be used and applied locally. Our speaker today is Doug Morrison, with 29 years of experience in the freight railroad, transmission, oil and gas industry, and municipalities. Doug has been focused on the application of advanced technologies within multiple industries. Experience includes GIS, LiDAR, aerial photogrammetry, database and software application development, positive train control, verification validation, and change detection management solutions. Our key strengths combined with the current engineering services, real estate, research and development, survey, and field operations. Doug has extensive knowledge and experience managing projects and teams in these diverse market sectors. So Doug, I'm going to turn it over to you.
Well, thank you. That's quite embarrassing when you read all that about a person. So, but
yeah, you have to just stand there and wait. Yeah, that's me.
Wow. Yeah, thank you, everyone. So honored to have the opportunity to talk about advanced technologies and just some of the things that are going on with trends in data and some of the technologies that are impacting data. So thank you again. Congratulations to everyone out there that is participating in graduation week or weeks. It's a busy time of year, but thank you for being here. So I thought I'd get started and just talk a little bit about kind of introducing the topic here and then going into digital transformation and what that means and how that impacts us and affects us on a daily basis. And then I did want to kind of start talking a little bit about what we're seeing from a trend wise with data maturity and what data maturity means in the technology realm and where that's going. And then we'll get into some advanced technologies and wrap up with some questions. So as you start thinking about data, a couple of things that we want to, I guess, kind of set the groundwork for here. So when we start talking about advancing technology, I think we all experience this on a daily basis, but it drives a lot of change in our organization and our businesses. And so we have to be flexible and scale and adapt to that change. And right now it's been coming out of the pandemic and all the issues we've dealt with from virtual interactions, et cetera. We've had to adapt to that change. And the one thing that stays constant is the data lifecycle. And I wanted to kind of go through the data lifecycle a little bit because it's really critical as we start talking about the digital transformation that we're going through, as well as the advancement of technologies that are impacting data. So if you think in just pure terms about the data lifecycle, we really have four major components of it, and we'll talk about technologies in each one of those components. But the acquisition, and that can be everything from how we acquire data in the field, whether that's survey collection, drones, to LiDAR, to mobile handheld surveys in the field, like if we're going out and doing a data collection on assets or something for the attribute information. Once that data is collected, then we have to figure out how to manage it. And really, when we start looking at management, traditionally we've looked at relational databases, but now with the introduction and the prominence of cloud technologies, we're starting to see data warehouses and data lakes and structured and unstructured data being managed, and how that all is being managed in that life cycle is very critical in how we will use that. And that leads us into starting to think about data maturity as we go along. And then the last two phases are really starting to drive decisions and visualizing the data that's coming out of this transformation. So that's where we have our analytics, and whether it be economic and financial type information, or looking at projects and program information, to asset management, and how we're looking at assets from a traditionally transactional base to maybe today and going forward with IoT to a non-transactional. And so it's interesting in how we see those kind of things changing. And then the visualization is the last piece, which is really where we use this data to really drive the KPIs, or the key performance indicators, to really understand and make decisions from what the whole life cycle has provided us from a decision-making standpoint. So as we start talking about that data life cycle and move into the data maturity, we're really trying to understand the combination of the life cycle of data with the maturity of that data. And so I have a couple of quotes here from Forbes that I thought were interesting, and that more data has been created in the past 2 years than in the entire previous history of the human race. That's fundamental. We have more than ever fundamental management issues with data now, and we'll get into a little bit about what's causing some of that change. But the other interesting fact, only about 0.5% of that data is ever analyzed and used, which causes another workflow type management issue that we have to start thinking about. So a subset of that whole management piece is the whole create, store, use, archive, delete, and purge. And so now we have to start thinking about data from a standpoint of what value does it bring to our organization, and if we're really going to gain value in the future from it. So, growing up in a technology and data world, I hate to hear or think of the idea of deleting data, but we are in that stage where now, sometimes it's not cost effective to store these large amounts of data, when really what we're wanting to get out of that data is the decision value from the data. So some of these data growth sources in transportation: LiDAR, BIM, IoT, social media listening, digital twins, and we'll talk about some of those as we move through the presentation here. So this is the real thing that I guess as a takeaway that I want us to think about when we start thinking about data maturity. So as you think about the life cycle of data, we start talking about data, and we use data as a generalized term. Data in the data maturity model is just facts, figures. It's just raw data. It's got a lot of noise in it. It doesn't drive a lot of knowledge or information. And that's the holy grail of data maturity, is that we want to really start using that data and move it up the pyramid so that we get to the real point, wisdom, which is where we and the data are intelligent enough that we are able to make solid, sound decisions for the future as we are calculating projects or economics of a project, or what it means from a climate study, or whatever it may be. So it gives us that insight into the future. So as we progress up through that pyramid, a lot of things happen to the data, and in a lot of senses, we start seeing the data start moving away from the noise and raw data into the information and what we can do there, and then into the knowledge. An interesting kind of fact I saw, one of the things that was out there was somebody asked a question of just how much data is being created, and they asked on a daily basis. And right now, with the consumer products that are out there, iPhones, Samsung phones, whatever phone, but the mobile phones that we have, so much data is being collected worldwide that there's not a real good number on it. But in general, the basic is that they figure that about 7 septillion bytes of data are generated daily. And so if you start thinking about that, our traditional hard drives are not going to satisfy some of the things that we need to do going forward in the future. And so this is where the cloud comes in as a very critical component in this data maturity and data management strategies. So I thought we'd go in and just talk a little bit about some of these advanced technologies and acquisition. And as we talk about large amounts of data, I think we're all very aware of just the vast amounts of LiDAR and the point data that's being collected out there. Some of the things we're looking at and seeing coming forward is, though, not only on the LiDAR side, but now we're starting to see a lot of IoT type sensors coming into our assets and structures to monitor them. This data is a changing the way we manage data, because that data traditionally has been very transactional. We would get a record set and we would filter it, we would do our analysis on it, et cetera. Now we have beacons and sensors that are streaming data to us on a constant basis. And so in this model of this acquisition, we have to start thinking about different storage capacities for that data. And so we're looking at data warehouses and data lakes where we're aggregating that data so that we can do that kind of pre-analysis before we actually determine the value of each data set and bring it into the rest of that data lifecycle. So I gave up here in the right corner some examples of just where this massive amounts of data is coming from. And so, I did put, a picture of a cell phone on there because consumers are taking pictures. They're sending us, information that they're collecting from their phones. I have a new iPhone and it has LiDAR capabilities on it. And so I can do LiDAR scans from my phone. Just the sheer amount of data that's data producing capabilities that is in every single person's hand that has a phone is pretty substantial. And we're gonna have to think about that and how we integrate that into some of our workflows. Now, granted, caveat, we still know that that data is not it's noisy, it's not accurate or precise for what we need on our engineering and design side of the house. But 10 years ago, if we look back at some of the sensors, they weren't either, and now we are in a different realm. So we just have to stay close to what's happening with those advanced technologies as they move 2 and 3 years down the road. So the two images here that have the kind of gray dots and stuff, those are just images of LiDAR. Some showing the bottom one there is showing where a mobile handheld LiDAR scanned the surface, and then they also scanned inside of a culvert and were able to show kind of a 3-dimensional above ground, below ground. Not very precise, but from a conceptual standpoint and thinking about going out and finding out what our environment looks like, it's pretty neat use of technology. To the right is a digital twin, if you will, 3D model of a building with multiple floors. The technology, as we take this and move into some of the analyzing and management of this data, it's getting more and more intelligent. We're starting to use some advanced technologies like AI and ML machine learning, where allows us to do some things where we can go in and actually select a floor, and it'll come out and pull and give us a floor plan of that area so that we can do further analysis. So driving down into that data and seeking that knowledge from the data is really exciting right now in today's world. Where it's going to be, it just continues to change, and it's on a rapid escalation. So as we start thinking about management, we have data coming in and it's impacting every single workflow inside of our organizations. And so this, I was trying to pull together some examples of just where this data that is coming in is impacting that, and where it's being used, and whether, you know, it's asset management or real property and real estate and parcels, to environmental information, projects, and even thinking about work orders and work order management, incident management. The data is coming in and is being managed in a central location. And then, you know, we also have two scenarios here where we have this integration of these large data sets coming in, one being on the project side, where we think about the data from a project standpoint, but then we also have it, you know, is a enterprise integration that we have to think about the integration into that enterprise with respect to, you know, how long do we keep this data? What's the life span of the data? Is it going to be archived? Are we going to reuse the data, et cetera? So through all of this, there's a verification and validation step that, you know, is critical, that has to be built into these workflows, because as we bring this into the enterprise, if you look in the center here, one of the things that we want to make sure is that this data has a sound, strong metadata record associated to it, which gives the source and record of that data, so that we know the precision, the accuracy, when it was collected, and you know, typically how long it'll be valid for. So a lot of things that are happening here, and a lot of this, as you see, is transactional type scenarios. And as we move into the cloud management type of environments, we're going to start seeing a lot of this data move to unstructured type data sets, where we're not actually recording or managing the transactions anymore. We're managing the raw information data sets and feeding into analytical algorithms. So more to come on this kind of exciting area of how this data is going to integrate into our projects and enterprise. So quickly, I just wanted to go over some analytics. I'm sure we've all seen these. These are dashboards. Dashboards are one of the really interesting things that's kind of come upon us on our data sets over the last 3 or 4 years. Power BI was a huge stepping stone. Esri and the ArcGIS GIS platform has dashboards. A lot of companies have dashboards, but dashboards are a quick visual interpretation, as well as an analytical engine that allows us to analyze this data very quickly and then show kind of a result from that. We can build scenarios in there. We can filter data. We can do a lot with this data to analyze it and come up with an example. So this larger screen dashboard here is an analysis of crashes in a DOT network. The kind of the pinkish over here is truck GPS parking, showing routes, origination, destination of trucks and where they're parking. And then the kind of segmentation of how much volume and kind of a heat map of what that looks like from all of that analysis of the data coming from the truck GPS. That truck GPS data is an example of streaming data that's coming to us. So, you know, all the GPS points in between the origination and destination provide us the routes, but the real data that we're looking for is that origination and destination. So visualization has really stepped up and came a long ways here over the last few years as well. And so I put this up. These are just some examples of all the different types of visualizations that we're seeing out there in the market. Kind of the three that I want to really draw your attention to is the whole project sequencing, the virtual reality, and the augmented reality. And this is where this data, as it's moving through its life cycle and its maturity, really is starting to change the way that we're using advanced technologies to, in the virtual reality, have a 3D visual representation of our projects and our designs and concepts. And then augmented reality is going in. And so I don't know if you can see this very well, but this is a full model of a project that is actually sitting on top of a conference room table, that we're able to actually see what the model's going to look like without having to go to the field. We can make design changes there. We can go back into our data and edit it as we need. And project sequencing, if you're not familiar with project sequencing, this is kind of using the augmented reality, virtual reality, 3D BIM models, and actually walking through the stages of construction so that we can see how the project is going to sequence and identify if there's any areas where we might have missed something in the design steps as we're going along. So what are some of the things that are really maximizing this data? And you've all heard the terms AI, artificial intelligence, but what we're seeing is that, artificial intelligence is really the catchphrase for something that a computer can do that a human does. So where we're really focusing our attention is on the machine learning and deep learning. So machine learning, think of that as algorithms, a set of, step-by-step code that tells the computer what to do. And it provides some intelligence as it's performing those tasks. You'll see this a lot of times when we're doing things like advanced feature extraction for LiDAR data, where we're wanting to extract assets out of a large data set of LiDAR data. And I'll go into some of the classes, as we call them, that we extract from the LiDAR data using machine learning. Deep learning, we get into neural networks, and neural networks allows us to really give a computer a model to learn by, and it starts asking questions. Simple terms, it asks us questions and it learns from our answers to those questions, and then it builds a model that it then starts giving us levels of confidence when it identifies something. So easiest one that I can explain is if you can imagine a street with street lights, it'll go through and it'll say, I have a model that represents a street light, and it comes across something that resembles it, and it will say, is this a street light? And the user will say, yes, it is, or no, it's not. And it stores that in the neural network and continues on down the training model, if you will. And once it gets to the end, it will have a subset of network paths that it will then try to extract that data on there, and it will give a level of confidence based on the models that it learned from. Really fascinating stuff. This is an area that is going to explode over the next couple of years, and really exciting to see where this goes. So I wanted to give some examples of just how this is kind of working and what we're seeing in the transportation space. So we have LiDAR data and we have aerial imagery, and we can use that interchangeably on that data. So what we're doing here is we're extracting road center lines, we're extracting edge of roads, we're extracting barriers, and these are all models that that we are looking at. From on the left is an image of what it is. On the right is the learning module that I was talking about, where we're giving the computer the information and saying, we want you to extract the center line. And it's going through and it's trying to identify or determine what that center line is. And through iterations of learning, then it provides us with a level of confidence. So it may say that this is a 90% or 95% confidence of our center line here. Doing this in a huge level of efficiency, whereas human interaction, this may take days, weeks to do this. Computers are doing this on large processing farms in a matter of minutes. And it's really changing the way we think about how to extract these data sets that we need for decision making from raw data. This is one that I thought was pretty interesting and kind of exciting. So this is kind of going into the neural network. So we provided information to the computer to do multiple things. So we wanted to segment vehicles, we wanted to segment buildings, we wanted to segment roads, etc. And so we gave it models, trained it up, and did a pretty good job. As you can see, it outlined the vehicles really well. It also outlined the buildings, and it did the road, edge of roads and center lines of roads. This is continuing to foster more innovation in these areas, doing these kind of things and seeing how exciting and just the impact this can have continues to drive more and more research into the AI world. So I mentioned classes. So right now, if you go out and look, the kind of the threshold when we feel confidence on an AI, ML, or DL, machine learning, deep learning model, is we reach 95+% confidence. And so right now, highways, concrete barriers, guardrails, yellow line, travel lanes, drainage, bridge barriers, overhead signs, these are all in that 95 to 100% confidence that AI has accomplished so far. So we're really excited to add more classes. So we call these classes of feature extraction that's being done by AI and machine learning. So more and more of these classes will continue to grow as we take more data and start building these models out for them. So I think that's it. I don't know how I did on time. I went a little bit long, sorry.
You did great. Thank you. Thank you, Doug. I don't see any questions in the chat. We have a few minutes left if anyone has any questions for Doug. This is a lot of great information. A reminder to folks as they put questions in the chat or before they leave for the day, we will start our sessions at 9 a.m. on Thursday. We hope to see you then. I'm not seeing any questions. So thank you so much, Doug. Thank you for coming today and sharing with us. And everyone, we'll see you Thursday morning.
Thank you.